Hello everybody, Daniel Hofmann here with a detailed look on 2D tilemap features in Unity's beta version 2017.3. In this video I will show you an easy way how procedural tilemap generation works. Your produced tilemaps, of course, stay fully editable, and you can even save them as a prefab for your own games. At first we will take a quick look at the game algorithm behind the scripts, then write some small functions so you can test out different parameters and compare the outcome. Sounds good? Let's get started. The algorithm we use today for generating tilemap terrain is based on Conway's Game of Life. It was originally developed for simulating organic-like structures, and since its first application has been used in a lot of different fields during science history. All starts by placing filled cells on a grid which are labeled as alive, and the non-filled cells are dead. This is done by an initial chance for each cell to become alive or not. After that, we will conduct a neighbor check for each cell on the grid. So the number of neighbors a living cell has is compared to its death limit, and in case this number is lower than the parameter, the cell will die in the next run of the simulation, meaning getting not filled. On the other hand, a cell which is not yet filled on the map but has more neighbors than its birth limit demands will become alive, meaning filled, in the next run of the simulation. The more often you run this simple algorithm across your tilemap, the more it will develop from a random filled chaos to a more and more organic-like structure. Let's start to fill this gray theory with some life by creating a new scripts folder under the assets folder, and within this folder we will create a new C# script. I call mine tile automata because this is perhaps the wrong pronunciation but the right name for the whole machine behind this, and open it up in Visual Studio, of course. The first thing I do here is to delete the start method. After that, I go to the top and we declare the Unity Engine tilemaps namespace and the Unity editor namespace, as well as we will need both of them during our scripting. And then we go on and declare some fields which are necessary for running the algorithm. The first is the initial chance of a tile on the map to be alive. We'll place a range selector above, which will be visible in the inspector later on, with values between 0% and 100. Of course, 0 would result in, well, not really useful simulation. The next parameters are the birth limit, an integer, and the death limit. And here as well, we give ourselves the opportunity to choose inside a range between 1 and 8, which seems useful to me. And then we have our next parameter, which is the number of repetitions we want to run the algorithm. We give it a range selector as well, 1 and 10 as a maximum should be the values of choice, and Well, a simple integer for counting the number of save files later on, which I set to 0 now. And another integer array which will store our terrain tiles, having a 1 meaning they are alive, or having a 0 meaning they are not filled. So then we need a vector3int for our tilemap size, and of course a tilemap class, or two better, one for the terrain and one for lava or water or whatever you want to put beneath. So one we call our top map, the other one will be the bottom map. And two types of tiles we need to place on the maps, the top tile and the bottom tile would be suitable names, I think. And then we have two integers representing the width and height of our tilemap. We take from our tilemap size vector3int. So yeah, we have two short variable names we can loop through when we write our main and sub functions. Our first function is the main function. I call it doSim for do simulation, and it will take in an integer, which is the number of repetitions. And then we want to call a small sub function. I call it clearmaps, which will take in a bool. So if the bool is false, this subfunction we write now should only clear the tilemaps so that there are no tiles visible on the screen, but our integer array of filled and non-filled tiles should stay like it is. And if the bool takes in a true value, then we clear this integer array as well, because it means we want to start a new simulation and not take the next step for an already existing tilemap. Both maps have a generic function called clear all tiles, which we call here inside this subfunction. And as I said before, if the bool named complete is true, we want to set our integer array to null. And now we start to fill our integer array for the first time with random tiles. But before that, we assign our tilemap size x and y value from the vector3int in the inspector to our width and height integers, so we can easily build loops around them. If our terrain map array is null, we want to first create a new one with the size of our width and height variables, and then we want to fill it with random tiles. So we call our init position method, which we write right now. It's public void, and it will, as I said before, loop through our width and height values of the tilemaps. So let's name them X and Y and change the width to height. And so if we have prepared our loops, we can now create a new random number for our terrain map at a given value. and this should be between 1 and 101 because 101 is exclusive. And in case that this random range is less than our initial chance we define later on in our game object, we will set the value at this position of the array to 1, meaning the tile is alive. Otherwise it will get a 0, meaning it is not filled. So let's continue to write our generate terrain method, which we will call the number of times we specified for our do simulation method in a for loop. So we will call this method with the terrain map array as an input and write back to the terrain map the processed vector 3 and tile positions as a result of our neighbor check afterwards. So let's declare this method, the int array first, gen_tile_pos I call it, and the int array as an input, which I will call automap also. Let's declare this new map array, which will be the output array after processing the old map, at the top of this method. Again, it will have the size of width and height of the tile map, and we will return it at the bottom. But before I declare the number of neighbors as an int, and now we loop again through width and height of this old map int array, meaning x and y values of the tile map. And inside this nested for loop, we will do our neighbor check, setting our neighbor to 0 first. And then I will declare bounce instruct, which is nothing else than like a virtual rectangle of int positions in x, y, and z direction around our current position, starting from -1 in x direction, -1 in y direction, 0 in z direction, and giving it a length of 3 and 3 in x and y, and 1 in z direction. So now we can place a for each loop inside our nested for loop and add this struct for each value to our x and y positions to get the neighbors around our current position. So we loop through our myBounce or myB, all positions within, and now comes a longer if statement. First we exclude the x and y value 0, because if x is 0 of the bounds we add to our position and y, then we have found our current position and this is not a neighbor, so we will continue. And now we want to exclude the values outside the map 2. So x plus the bounds in x direction have to be greater or equal 0 and less than the width of our map. And y plus the bounds y value have to be greater or equal 0.2 and smaller than the height of our map. So if this is the case, we will add the value of our old map to our neighbor counter. And else we are at the border of our map and we simply want to count a neighbor here as well to draw a border around the terrain we generate. So after we have done this check for a given tile at a given position, it's time to compare the result with our values for birth and death limit parameters. If a tile at a position in the old map equals 1, and in that case if the number of neighbors is below the death limit, then this tile will not be on our new map, meaning it will receive a 0 value. Otherwise, if it is equal or higher than the death limit, we will transfer this tile position to our new map, giving it a 1. And the same check with a different parameter has to be done for the tiles which are currently 0 in the old map. So if they have a neighbor count higher than the birth limit, they will receive a 1 in the new map, and else they stay dead. So that's it for our generate terrain method. I think this was not too complicated. So what is left behind for our main method is that we simply want to place the tiles from the processed list on our tile maps. So one last time we loop through width and height, and if we find a tile which has a value of 1 at a position in our terrain array, then we will place it on the map using the top map set tile function, which needs a new vector3 int as an input. We use the -x plus width divided by 2 and -y plus height divided by 2, because we don't want to start our tile map at 0, 0. And we place our top tile on the top map. There's something wrong here. Okay, it's not send message, but set tile, of course. So, and for every position on the bottom map, we will set the bot tile as well. No matter if, because we did not process this in another method, we want to fill this map completely because it's our map for lava, water, and other fluid-like stuff. So one last thing, good way to start the simulation is to use our mouse button. So we go to the update method and check for input, get mouse button down, and for the left mouse button it's 0, and in this case we call our doSim method for the given number of repetitions. And in case we want to clear the time maps and start a brand new simulation, we can also place below our clear maps function associated with the event of hitting our right mouse button. So in this case we call the clear maps function with a value of true because we clear the time maps and our int array as well. So going back to Unity, we can now create an empty game object for our tile automata class. I name it like the class and drag our script onto this game object, and now we see all the sliders for our values we need to specify for the different parameters. We can already choose like for example the time map size in X and Y. I'll take a small one for the beginning, and we have 4 slots, 2 for each time map and 2 for our tiles. So it's easy for us to create the time maps now. Simply choose game object 2D, and this will place a tile map with the corresponding grid in our scene, and we click on the tile map, name the first one top map, and then again we go to 2D objects, game object menu, and call that one our bottom map or bottom map. We quickly change the ordinal layer for our top map to 1, so it's above the bottom map. And now we can drag both maps into the empty slots of our tile automata script. To create the tiles, we click on Assets, Create Tile, store them wherever we want to, and one will be our top tile, and the other one, of course, our bottom tile. So what is next is we have to choose like a sprite for our tiles so we can display them in the scene. For this purpose I've created a simple 24 × 24 white box sprite, which I drag into the folder and quickly adjust the import settings for this one with the pixels per unit of 24, a filter mode of point no filter, and a compression of none. Now we can select this box texture and assign it to each of the tiles we created with a difference in the color we choose. So the first one gets a bluish-like color from me, so it's more like a water tile for the bottom map, and the second one gets a brown color as it stands for the terrain, which we simulate on our top map. And now we simply drag our ready tiles into the slots prepared for them as well. Before we start our simulation, I've decided to slightly adjust the values to give you a better impression what we are aiming for. So I give the simulation an initial chance of 25, a birth limit of 3, a death limit of 2, and a number of repetitions for each simulation of 1. And I resize the tile map with an X value of 120 and a Y value of 70. I adjust the camera orthographic view to 45 as well. So if we now enter play mode and hit the left mouse button, ta-da! You see like the top tiles on top and the water tiles at the bottom, and every time you click the left mouse button the structure gets rounder and more island-like shaped. So I strongly encourage you to play around with the parameters, because you could be surprised in different scenarios of the outcome you receive. And if you don't like the border, just comment it out in our tile automata script. The last thing we want to do here is to save our map as a prefab. So let's do this in the update function by calling a method in case we press the middle mouse button, which is number 2. I call the function save asset map, and this is the reason why we implemented the Unity editor namespace, because we would like to show a quick response field. So let's write this function. It's a void, and we start by declaring a string file name. I call it save name. Give him a name of your choice, something perhaps which does not bear the danger of overwriting something else. To prevent this, I implemented the counter too, and we simply search for our grid game object by name, and if this search is successful, returning true, our save path under assets and save name will be composed, plus the ending prefab. So now we call the prefab utility, and if we successfully create a prefab under the save path, we will display a quick box on the screen using our editor utility, and the function is called display dialog. And I write in some short title and a quick message that the tile map has been saved successfully to the folder and file name we specified, and complete this step by inserting field for the user, or better a button, to continue and end this dialog. So, and in case the save procedure was not successful, we also want to react by displaying a dialog, this time giving feedback that some error occurred. So this is just one hint how to do the storing Again, this is not fireproofed, so it bears the danger that you can overwrite something. So now if we try this out during play mode and you press the middle mouse button, you should get some weird message. So now you can find your saved asset prefab under the assets folder, and if we delete the tilemap we have now in our scene and drag in the asset, you see it there with the save name we specified in the hierarchy. And if you create a new palette, you can go ahead, perhaps start by dragging in our terrain and water tile, and now you can choose the brush and edit your maps like you want to. We are slowly coming to the end of this tutorial, but the best is yet to come. Things get interesting and more appealing on the next level by using your own scripted tiles and multiple layer. As a demonstration, I've put my own tiles into the project folder, like a cave tile, water and lava tile. You just have to quickly adapt the fields in our class to the new tile types. I've used a terrain tile and the water tile is an animated tile. Go back to our tile automata class and drag in the new tile types. Then enter play mode. Start the simulation by clicking left and tada! Things look more appealing and at least like a raw in-game tile map. You can even drag different tile types on the fly during play mode and get a complete new landscape. If you want to learn how to do your own scriptable tiles, check out my previous tutorials. As always, I've uploaded project assets to my Dropbox. Feel free to download and modify. And if you like what you have seen, please help me to take this channel to the next level by subscribing. I promise I'll be back with more Unity tilemap stuff, so thanks for watching and see you soon.